About 2 years ago, I got a grant from the Institute for New Economic Thinking for building what I call the dynamic monetary simulation tool, which I gave the name of Minsky to. Since then, I also ran a successful Kickstarter campaign raising about $80,000 from the public. Thank you to you if you're one of the people who contributed to that. And I'm pleased to say that after between 1,500 and 2,000 hours of total programming time, we finally have a version of Minsky that I'm happy to regard as a version 1.0. If you've used Minsky before we got to this particular point, you would have found quite frequently a range of things happening. Either the program was incomplete in some way, it didn't look all that crash hot, there were bugs which would make it crash when you did something correct, something wrong would happen. That's the life of developing software from the very ground up. There's no such thing as a software program without bugs, and of course in the very early stages in which the industry calls beta and even alpha versions of the software, you get numerous bugs. So this is the very first time this Minsky's ever been written. Of course there were tons of bugs. We think this particular version has had most of its bugs eradicated, and it has a basic feature set that I think will work for the type of modelling it's designed to do. So if you want to give Minsky a try, you need to go to our SourceForge page to download it. And if you go there and you're a Windows user, it's simply a case of click on the green button and you will then get to this particular page, and in a short while the install will start and you'll see this turning up in your subdirectory down here. Now if you're not a Windows user, if you actually belong to the Macintosh world, or you're a Linux user, then click on Browse All Files and you'll find binaries here for Mac users, and it's source code for Linux people. We know that you tend to be people who like to compile their own programs from the code up. Of course this is open source software, so you can download the code, and if you want to get involved in changing the code or whatever else, we're delighted to have you help out with coordination through Russell. Now once you've done that, you will then have a WinZip file turning up, and inside that, if you then unzip that file to any location you like, I'll make a download, or I've already got that done. I deleted that one. I've already done my installation. After you run the install file, you will then find that you have Minsky installed on your palette. Most likely when you first use it, you'll find it inside a Minsky subdirectory here. I've used it so often, of course, that it turns up in my default programs. Click on the icon and you then see the overall system. Now this is obvious to an engineer. It's a system dynamics program. There's dozens of those in the industry. The industry leader is called MATLAB's Simulink, which I think sells for a retail price of what, $20,000, and MATLAB Mathematica's System Modeler, $3,500. If you want a free version of software like that, there's X costs, so there are plenty of programs out there that do what Minsky can do, and I'll quickly show that for those of you who aren't used to it, and that is that it lets you build an equation graphically using these icons up here. As you can see, the tooltips for them there, and variables, integration blocks, usual mathematical operators, and so on. Now I'll just do the simplest possible thing. I'll bring down this plot of time. Notice if I click on the icon here, then over in the right hand end of the window there, I will get a graph turning up. When I move the mouse down below this level, the graph comes down onto the screen. So I've got 3 there, mucking around a bit. If they're too small for you, by the way, right click and you can choose here resize. You then get a bounding box, bring out to the size you like, click on the mouse button, you've got something which is made a bit larger. If you'd like to have a label for it, you can click on options there, and I might just call this sine wave. But that's what I'm going to put in that window. I'm going to make a deliberate mistake here. Here's sine. You might think you bring it down, click on sine. Now notice over here I've got wire. The way that these equations are designed is by using a wire to assign a value from one point to another. And if you click on the wire mode here, you now go from moving things around on the palette, as you've seen I've been doing, to wiring things to each other. So I'll wire the sine over to there, go back to move mode, just to avoid bringing in extraneous wires if I clicked in the wrong place. Click on run, and I get an error. Now, what that's actually telling you is that you're simply saying sine without saying sine of what. So what I should have had there is sine of some input, and let's just make it t for time. I'll also wire time down to this graph down the bottom here. So click over to wire mode here, drag a wire from the tip of t to the input on sine, and from the tip of t down to the black input down here. Click on move mode again and choose run. and I get obviously a constant over here, t being because what the graphs do on the default is if you don't actually put something on the bottom icons down here, it presumes you're graphing against time. So I've made that explicit here. Now that's a pretty kludgy looking sine wave. Let's just stop it and slow it down quite a bit and watch it build more slowly. It's roughly a sine, but you can see it's jerky. The reason is because of the step size we're taking here. Now you should work with the finest step size, and what's called the Runge cutter algorithm controls that, and rather than have the maximum step size of 0.1, I'll make it 0.01. And run the simulation again. And then you see more the sort of sine wave you're used to seeing, but of course now it's rather slow, so let's just speed things up a bit. There you're seeing the basic sort of sine wave you're used to. So what have you actually done in terms of an equation? Well, if I save this, just call it demo, which is it? That's in my drive C. I'll bring it across to drive D over here, just call this sine. Now let's take a look at the equations behind sine. I can output that to another file that I'll also call sine. This will now become what's called a LaTeX file. And if I go across to that subdirectory and take a look at what do I actually have there, this is my own the LaTeX editor that I prefer using called Vacoma Tech. Ain't nothing there. Now why is that? Because I haven't actually defined an equation. Let's bring a variable down here, call this variable Fred. Place this here. Now let's get rid of, let's make this whole being Fred is equal to the sine of t. So what I want to do is, let's just drag sine over here a bit. Right click on that Y, and notice once the blue dot turns up that I get the capacity to do two things. One is delete, straighten, etc., etc. The other is curve a Y, but I'll leave that for a moment. Click on Y mode over here again and drag up to Fred, and then attach this down here. Choose save, and now export that as LaTeX. Just overwrite the one that's currently there. Go and take a look at it now. And now have Fred is equal to the sine of t. So what you're building is equations using a flow chart rather than writing them by hand. Although it is typical equations that a program like MathCAD or Mathematica and so on. Now there's tons of programs that can do this. Why did we write Minsky? The reason is one thing that's very hard to do with flowchart software, and I'll illustrate this with a later comparison, is to model the financial system. And the reason for that is the financial system, I'll just create a new system here to show you this. Financial system involves a transfer of a flow of money from one account to another. And you must make sure your signs are correct all the way through. And trust me for the moment, I'll give an illustration later. That's almost impossible to do with the flowchart metaphor. But it's quite easy to do with the metaphor that we can thank Godley for, pardon me, and the accounting profession itself, the double entry bookkeeping table. And I've named this in honour of Godley, who emphasised the need for economics to be strictly correct with its accounting. There's a bank icon created the same way that I bring down any of these other icons. Right click on it and I can choose open the Godley table, and I then see this view, which is the beginnings of a double entry bookkeeping system. Notice it says no asset class. We have to tell from the accounting point of view what each of your accounts are when you're putting a banking model together. Are you talking assets, liabilities or equity? I'm going to start with assets, of course, and say from the let's imagine we have loans, which I'm going to have just being to the banking sector here, but there's loans as an asset class. When I move away from that, in a moment you'll see the word loans pop down the bottom of the bank icon. If I can click on the plus key here, I now insert another column. I'm going to go straight across to talking about liabilities from the bank's point of view, and I'll say it lends to the firm sector. And if I then click here, add another column in, the firm sector, once it has borrowed money from the bankers, can hire workers, and of course the whole reason that the banking sector is doing this is to increase its income, and I'm going to call this a safe into which it pays the interest that it gets from giving a loan. That's created 3 banking accounts: loans, firms and workers. And let's now start with an initial loan. Let's say there's an initial of say $100 million. Once I type 100 here and move away, you'll see the row sum is 100. And what we're doing with the Minsky program is enforcing the strict double entry bookkeeping requirement that all rows must sum to 0. So if I now need to say what the loan is, it's created a deposit also of 100, which I'm going to show as a negative, which from the point of view of the bank, the liabilities are a negative to it. The row sum is now 0, so my accounting is correct on that particular row. I'm now going to show, let's say the banks lend money. Well, that means they're going to be doing a flow of lending from here. Now I've got positive lend over here. I've got to type minus lend somewhere, and I type minus lend in the firm's account. Click on here to add another row, and let's say what are the once you've been lent money by the bank, of course you've got to pay interest, and I'll have interest being paid from the firm's account across to the safe. So I need to have a minus interest here, and then you can repay the loan. So the repayment is going to be from your account, which is shown as a positive because it's going to decrease the amount of money in that bank liability, because it also decreases the lend that you're making. Now I'm going to make a mistake here, and notice once I do this, the program shows me, aha, I haven't got the same term. This doesn't balance to 0. So if I click over here and then hold the control key down and type the arrow key until I get between the P and the Y, if I type the A there, the program will now tell me, okay, you've got that particular sum right. Now, why do you borrow money? Not just that you can pay interest on it. You normally do this as a capitalist to hire workers. So we're going to have you paying wages to do that, and wages go from the firm's account to the bank, the workers' account. And once you have that money, of course, the workers will consume. So I'll just show this as CONS as an abbreviation, underscore, and I'll show you why I use underscore in a moment, W for workers. And over here, I have to type the minus cons underscore W. Notice the W is subscripted down here. We're using latex controls to give us some formatting. Strangely enough, none of the other programs in the marketplace have done that. And let's say bankers also buying intermediate goods from the firm sector. So I'll just call this I say bank, and I'll make this underscore curly brackets, INT for intermediate. And notice that when I do that, the whole INT is subscripted. If I type over here and went to banks underscore INT without the subscript, the program interprets that as two separate commands. So what I've got to do is get over here, right arrow key until I'm right against the INT, right arrow key over to the other side of the INT, press that bracket, and I've now got the wrong sign because I wanted to show this as being a payment, so I've got to make the minus key there. And have I got it right? Okay, what have I done wrong? This is good to make a mistake like this. I've probably got a double underscore there, I think. Let's go. Okay. Minus bank. I had bank plural, didn't I? My mistake. Underscore INT. Ah, my silly keyboard on this laptop moved away. Let's go back and try that again. Okay, so the row sums are all correct there. And let's just save this. I'll call this, let's again go back to my Minsky subdirectory over here. Call this Godley. And now if I export the equations, let's see what I've actually defined here. So I'm saying we have flows coming into the banking sector of lending, interest payments, repayment, wages, consumption by workers, and intermediate purchase of goods by the banking sector, going through 4 accounts: loans, firms, workers, and the safe. Let's output the equations of that system to see what they actually look like. And I'll call them Godley. I've got to go back and delete the MKY there, which is something we'll need to fix up at a later stage. We haven't quite fixed that file naming as yet. Let's go across and take a look at the TeX file. And there you've defined the basic flows of a financial system. This is the rate of change in the amount of money in the firm's account will be the inflows of new lending, consumption by workers, and purchases of intermediate goods by bankers, minus the outflows of interest servicing, repayment of debt and paying wages to the workers. Loans will grow with the lending and fall with repayment. The amount of money in the safe goes up with interest payments and goes down with bankers' consumption for purchase of intermediate goods, and workers' inflow as wages in, consumption out. So that's a very simple financial system you've defined without yet putting the elements of a numerical simulation into the system, and I'll do that in the next video.